Hello, what we're going to be covering in this video is how we can go ahead and use Python to read data that is formatted using JSON. So in order to do that, we need to go ahead and use a specific data set. So what we're going to be using in this example is earthquake data for the last 7 days. And the information, where I found this information is if you go out into the earthquake.us.gov site, there is information about how you can go ahead and download GeoJSON data from their website. So let me go back level, and there's the summary feed and the detail feed, and then down below there's information about what's actually in the file. So if we click on the detailed feed, it specifies all the key value pairs. So JSON data, all it is it's a large dictionary that contains information. Since we've worked with dictionaries before, if you know the keys, you can pull out the values. And all websites where you work with JSON information, they'll provide you those key value pairs, so you can go ahead and analyze that information and determine what information you want to basically pull out of that JSON data. So let me go ahead and go back into Python. Next thing I want to do is I just want to open that file. So as you look at that file, it's very dense and hard to read. So what we're going to be using is we're going to be using the JSON module, which provides a variety of tools for exploring and working with JSON data. Some of these tools will help us reformat the file so we can look at the raw data more easily before we begin to work with it programmatically. So that's what we're going to do next. So let me just go ahead and close that file and open up a new file. Create a new file, so it'll be a new file. And the first thing we need to do is we need to go ahead and import our JSON module. So again, this is for free. You do not have to install the module using pip. After we import it, we're going to go ahead and gather the file name of where the data is actually stored, and we're going to do that using an input statement. So it's just enter the path and file name of the file containing the earthquake data. And then after we get that file name, we need to open it. So that's what we're going to do next. Okay, and then what we're going to do is we're going to store all the information that we read into a variable called all EQ data. And what we're going to use is we're going to go ahead and use the JSON load function to load the information. So the JSON load function converts the data into a format Python can work with, which is just a giant dictionary. So that's our first step. The next step is, in order to analyze the data a little bit better, we're going to create a file to write the same data into a more readable format. And what we're going to be using to do that is the json.dump function to do that. So we're just going to go ahead and create a file, a variable for a file that we're going to save the data into. And what it's going to be okay, and then what we need to do is we need to open our new file. our readable. And we're going to save it as readable_eq_data.json under the CIS 156 directory. And we want to write data to that file. And then again, we're going to use the JSON dump function to do that. So we're just going to pull out of the data out of our all EQ data file. And we're going to do an indent equal to 4. So the indent equal 4 argument tells the dump function to format the data using indentation that matches the data structure. So let's go ahead and save and run our module. So I will go ahead and save it under CIS 156 as earthquake. And we need to go ahead and enter the path and file. So it is just C:(CIS 156). And it is EQ_data_7_day_m1.json. Okay, so it looks like it wrote information to our file. We have our readable data file, so I'm going to go ahead and open that up with Notepad++. And now that's a lot easier to read. So if we go ahead and look at the top, we have some metadata, and that just contains information about the file. It lets us know where we gathered the information from, the title, and then the one thing we're interested in, the count. So basically we have 1,304 earthquakes that we have information about. And then now if we go ahead and look under features, so that's our key to all of the data for each of the earthquakes. And then if we dig down a little bit more, we get into the properties. And then within the properties, that's where the bulk of the data is. So by using this type of format and using properties, geophysicists can add in as much information as they need into their JSON for the information that they want to capture. So some of the information we see is the magnitude, the place, the time of the earthquake. There's actually URLs to earthquakes. So if I go ahead and click on this first URL, well, let me see here. Let me go ahead and copy and paste it into a browser, and we'll go ahead and see what it actually looks like. So there's a URL. It has information about each one of the earthquakes in this file. Let's go back into it. It has the title of the earthquake, a bunch of other information about it, and then down below some important information. Under geometry and coordinates, basically what this shows us is it shows us the longitude and the latitude of where the earthquake actually occurred. So if you want to go ahead and plot this out on a map, you could just go ahead and grab those coordinates and use some plotting software, and you would be able to plot each one of these earthquakes on a map to see where they actually occurred. So now that we know what's in the file, what we're interested in doing is pulling out both the magnitude and the longitude. So we're going to go ahead and write the code to do that. So let's go back into our Python file. And what I'm going to do is I'm just going to go ahead and comment this code out, since we've already created that file. So what we want to do is we want to make a list that contains all the information about every earthquake that occurred by taking the data associated with the key features, and we're going to store it in all EQ_DICs. So I'm just going to go ahead and create a variable all EQ_DICs for dictionaries, and that will equal all our EQ_data, and the key that we're looking for is features. So we're just going to pull all the information found under features and store it in this dictionary. And the other thing we're going to do is we're just going to go ahead and print the size of that dictionary that we're creating, just to verify that we pulled in all of the information that is contained in this file. So as you remember, I think when we looked at the file originally and looked at the metadata itself, there were 1,304, so that's what our DICS file should contain. So let me just go ahead and run this now. And again, I'm just going to copy and paste my path. And we get 1,304. So now we know that our all EQ_DICS has all of the earthquake information in it. So what we need to do next is we need to create empty lists to store the magnitude and the longitude. So I'm going to do that. We'll just have mags, lon, and that will equal 2 empty lists. And then we're just going to iterate through our all EQ_DICS file. And each earthquake will get saved into EQ_DICT. So that'll give us access to each one of the earthquake's data. And then we want to pull out the magnitude, and we're going to go ahead and store that as a float, since that's the numeric representation of it. So it'll be EQ_DICT, and then if we go back into our file, after features, we can find magnitude under the key properties and under the key mag. So that's how we're going to access that. So it'll be properties, as our first key, and then mag as our second key. Well, I need to... Okay, so that should access the magnitude information. So what we need to do next is we need to go ahead and access the longitude. So it'll just be our lon, and it'll just be our EQ_DICT. And now we want to figure out how we're going to access that information. So if we go back into our file and click under, it looks like we need to access geometry is the first key. Coordinates is the second key, and looks like there's a list that involves 3 different fields. So our longitude is at position 0 in that list. Our latitude is at position 1. So what we need to do is, in order to access the longitude, it would be at position 0 in our coordinates list. So let's go back and create the code to access it. So it would just be geometry. And again, these keys must match exactly. So they must match spelling, the case must match exactly, otherwise you're not going to find the information. And then finally at position 0. So that should pull out our longitude, and then what we need to do after we pull out that information is we just need to go ahead and append it to each one of our lists. So we're going to append mag to our mags list, and we're going to append lon to our lons list. And let me see here, make sure I got everything spelled right. Okay, so that should be all we need in our loop. Is we're just going to gather, pull out the magnitude and the longitude and store them in our mags. And let me see, I want to change this to lons. So there we go. We want to make sure that is plural since it's going to contain multiple information. Okay, and then as a final check, we're just going to display the first 10 entries in each list. So we'll do a print, and it'll just be magnitudes, and we'll just do a slice of our list. And then we'll print longitude, and we're just going to print out the first 10 entries. Okay, so let's go ahead and see if we made any mistakes, see if we can actually pull out the information. So again, I've copied the file path, I'll hit enter, and it looks like we got some information back. So we have magnitudes 0.96, 12, 4.3, so at 96, 12, 4.3, it looks like it's pulling that information correctly. And my longitude 116, 148, 74. See if we got that right. 74, negative 148, 116, 79, 41667. Yeah, so it looks like we are actually pulling in the correct information. I'm just going to scroll on down, see if I can find about where the last entry was. We got a mag of a 4, so we're right at that entry. And that's 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5. That should be a negative 144. Yep. So it looks like we are pulling the correct information. So again, this is kind of just a short little example to show you how you can go ahead and use Python to pull information from JSON data that you've downloaded from the internet. So that's all I had for this video.